Okay, welcome to this quick tutorial on how to set up the ESP8266, which is the predecessor to the ESP32 on Linux. So specifically, let's see, so Linux 2404 Ubuntu, right? And so first thing you're going to do is just search up, ESP8266. We're going to use the RTOS SDK specifically. I know there's like other stuff that you can do with MicroPython for ESP8266, but I'm going to be trying to set up RTOS just because it's a bit more involved and you get a bit more flexibility, I think, as well. So we'll just open up this Get Started page. This is the accompanying GitHub repo. I think we'll need to copy this later, but all the instructions should be just on here as well. So, help you set up the environment. From version 3, I think, onwards, they've got this other thing called ESP-IDF, which they're using for the ESP32. And so they basically just like ported it to be like similar code style and stuff, I think. But it's still its own separate thing. So what we need, PC, toolchain, this thing, text editor, and the board itself. So that shouldn't be too bad. We've got a PC and we're about to get most of the other stuff. So what we're going to do first is, okay, which OS are we on? We're on Linux in this case, so I'll open up that page. And so first things you'll want to do is copy the stuff here, but not all of it. Just a quick note is that basically Python, if you try going sudo apt get install Python, you will see that there's actually no Python package, but there is this Python is Python 3 package. The way that I fixed that when we have to run Python later is you just run Python 3 instead. So I guess if you want to, you could do, you could go Python 3 and make sure that's installed, but it is for me, so that's not a problem. Other thing is Python serial is a module for Python, so that'll be handled by the module stuff that we'll do later. But yeah, just try to run everything up to, but not including the Python commands over here, just because they mess up stuff a bit. But yeah, if we try copying that, paste it in here. Looks like I've already got everything installed because I'm trying to do this tutorial. I've already, done this the first time. But yeah, now we want to grab the toolchain, so that'll be 64-bit Linux. Let's just chuck that there, I guess, why not? And then, yeah, I guess we'll follow these instructions, though you can do it through the GUI as well, because it's a bit opaque for me anyway. So what I'll do is I'll go over here to the folder where it's downloaded, so that's the one. On Ubuntu anyway, I guess, GNOME, I don't know. You can basically double-click the thing and it'll automatically extract it, or you can, press the extract button, and it should be here. So it's now done extracting. So we open up that folder, and what they're going to do next is, they make this ESP folder in the home directory. I guess we can do that. So make directory, I think they do /r. Do they do? I don't know what -p actually does, but yeah. ESP and then CD ESP, because we were just in the home directory anyway. And so what they were going to do is then copy the extracted file into there, which is maybe a bit faster, but yeah, I'm just going to copy and paste it like this. So we go like that, Control X, go into here, Control V, and that is the same thing. Cool. So with that done, we want to add this to our path, I guess, so that we actually have access to the executable. So what we're going to do is go back to our terminal, clear that, honestly, and so we're in this folder over here, but honestly we can just go to the home folder just for a second, because we're going to be changing the bash config. So I think nano should be installed on most people's machines, so I'll go to nano.bashrc. I mean, if you're using fish or something else, that'll be different. But yeah, it looks like these paths are the ones that I used from before. So yeah, you'll want to do that first one, which is to actually add ESP8266's toolchain, which is what we just downloaded. So this thing over here, add that. So it's your home directory, which is what this $home. Oh, sorry. So path directory, we're adding to the path directory $home, and then we're going. Okay, the ESP folder, and then within that, this folder within that, and then the binary folder, which is going to have all the executables. And we can, forget that for now. Forget the second line. We'll get to that in a second. But, yeah, that's done. And then the second thing I would maybe recommend is this. Oh no, that's later. That's later. So yeah, if we now want to check if that's actually saved, we can go Control D, and I think I have another terminal session open. Yep. So now if we try, it'll show it anyway. But if we go echo $path, we can see that over the end here we've got this, extensa LX106 stuff. So yeah, we can use that. That's working. Next thing to do is this permission stuff. So sudo user mod. This is basically just adding the user to the dialogue group. And so what the dialogue group does, it means that you can actually flash the microcontroller. Otherwise you can't do that, so that's a bit of a problem. And so we'll just copy this command, go to our terminal, paste the command, add in my password, and then go groups me, or I guess you could go groups $user, and that's the same thing, just taking the immediate user. And so we can see that that's there, but later on we will see that that didn't quite work without a few other steps. So we'll go back. Looks like we want to just go to this page, which is the same as that page. So next thing to do, this will kick in for us. Maybe not, I don't know. That's fine. So besides the toolchain, which we just got, we also want to actually clone this repository. So we'll go over to the ESP folder and then copy this git clone command. So Control C, Control V, make sure that everything's good. Press enter, and if we check in here, we will now see that there's this new folder that it's adding for us. So it's also recursively adding all of the dependencies, so these submodules and stuff are going to get copied over as well. And then once that's done, we will, I think, want to add the ESP IDF. Okay, cool, yeah, I just reloaded it. So we'll add this path variable, which is there for me, but you'll need to add it. So we go, once this is done, or I guess while this is happening, why not? So what you can do then is open up a new terminal. So I did Control-Alt-T, which is just a shortcut on Ubuntu. I don't know if it works on other distributions, but what you can do then is go, I guess I'll do vim.bashrc just because I like vim. And so go to the very bottom of the page, which you could do a multitude of ways. And then I've got this little comment that says add IDF path to environment. So let's just remake that, add IDF to environment variables, or I guess add IDF, because it is an environment variable. And so what we do then is we export IDF underscore path is equal to, and then use double quotes. And so the actual path itself is just the Git stuff that we just cloned. Like that is the path. So if we go to cd ESP8266 RTOS, this is like the path that it's asking for. So I'll honestly just copy that, and then I'll go home slash, and then that, and that should be that. So if we go quit, and then we Control D, and then I Control Shift, it's not whatever. And then if I go echo IDF path, it has that exact folder, which is this folder. That's good. So next thing to do is install the required packages in Python, but there's an extra step that I'm going to add in here because I think it makes stuff a bit easier. So that's adding a virtual environment. So if we go back into the ESP folder over here, what I'm going to do is Python 3 -m, so for submodule virtual environment, and then we're actually going to put the virtual environment in the virtual environment folder, which I hope works. So let's try doing it like that. I don't know if that's going to work for me, but I'm currently in the ESP folder, and then I want to put a virtual environment folder within that. So it would go cd vnv, nice. So yeah, this has our required files. So what you want to do then is basically every time that you're actually doing anything with the programming the ESP, you'll go, let's actually just simulate it. So if you're in the home directory, you just open up a terminal. Then you will go like this. Here you go, source tilde for home environment, and then ESP, and then virtual environment, and then bin, and then activate. and then you'll see this little venv thing. That means that now everything we run is within this like local virtual environment with its own dependencies and own other stuff, so it doesn't actually mess up the rest of your like. If you have other programs, if you do other stuff on Python, it's not going to mess it up. So it'll just be like its own little isolated container, if you want to call it that. So what we can do then is we can actually use the requirements that are in this folder. And also one thing to note is that since we've got a virtual environment, we don't need to do the user tag. So I'll just copy this, paste this, and as you'll see in a second, I don't think it'll work immediately because there's no distributable called Python. Oh, okay, never mind, it does work. And I think the reason for that is if I go into Vim, I think it's probably .bash aliases, yeah. So I already added an alias that says Python is Python 3. So yeah, you probably won't have that, but you can certainly add that and do this, and then that's fine as well, and this will work the same. But yeah, basically, that command that we just ran, which is python-m pip install, the -r is saying we're using a requirements file, and then there's the actual location of the requirements file. So then it's going through all this stuff. I already have it downloaded, but obviously yours will take a bit longer maybe. But yeah, once that's done, then we can go to the next step, which is to actually open up a folder. And I think we're going to be using this example folder. So yeah, we will go close that, I guess. And then cd esp, and then they're copying recursively from the idea path / example / get started hello world, and we're doing that dot, which means in the current directory, so we should get a folder right here called hello world, and that's what happens. So we'll go into here, and then we'll try and see what's going on here, and basically what it tells us then is that if we want to actually make the folder, there's a few steps. The first one is to run this make menu config, and so that will open up a thingy of some sort, a thingy, very technical. Oh, what do I need? Python, no such file environment. That is not something I was expecting to see it say. Oh, it's because I don't have it sourced, my bad. So it's literally what I was saying. So if we go source, ESP, virtual environment, then activate. Now we see the virtual environment tag, so that's a good reminder for you as well. And so now if we try doing make menu config, then it will be happy and we can open this up. So now from here, we're just basically going to serial flasher and making sure this is on the default port. I'm happy with that baud rate. If you don't really know what any of this stuff means, honestly, why are you doing the RTOS SDK? Just use MicroPython. But yeah, no, like you can, mess around with some of this stuff. I think 40 is fine. I'll just keep it in stock, honestly. It's not a big deal. And so go save, press OK, press exit, and then we're just going to exit this menu out entirely. And it will say something about, I don't really care about the get set up for this thing. But basically what we can then do is try flashing. So we'll go make flash, and this will fail for one reason. I mean, it will actually build it. It should be fine, but I don't think it's actually going to flash onto the board, and there's an important reason for that. And it has to do with the dial-out group. So you'll remember that we earlier ran the command sudo user mod, or whatever, we added ourselves to dial-out, right? Like if I go groups, for me, it has dial-out there. The problem is, this is only really updated once you actually restart. Like, not your terminal, but your entire, instance. Like, your login session. I don't know what it's really called. But yeah, you basically have to, I don't know if logging out and logging back in will work, but I know that restarting my computer actually does this. And so otherwise, what we'll see in just a second is that it won't actually be able to access that folder. Like, it won't be able to access the, /dev tty us, sorry. Oh, sorry, yeah, that's not a folder, is it? So if we go, cd dev, and then we go grep tty USB 0. Oh, there's nothing plugged in, my bad. I've got to plug in something, so that actually will mess up the thing anyway. Oh yeah, at this point, I should mention you should plug in your microcontroller. So now that's plugged in, we should be able to grep TTY USB 0. So that's fine, that shows up, but I don't think it will actually flash to it because it won't really have permission to. Generating the thing, and yeah, so permission denied to this, and then over here it says it could not open the port, and so the reason for that is because I haven't restarted yet. And so what I'll do next is, without changing anything else on this, I'm just going to restart the computer. We'll see if it works after that, and then if it does, you basically have the RTOS set up, so that's pretty good. And then you can start, developing, looking through the examples and stuff. But yeah, just a second on that. Then system ctl reboot. I'll probably close OBS so that doesn't bug out. Okay, as I was editing this, I actually had a quick thought, which is on everyone's machine is sort of different. So when you go into this dev folder, right? If I go ls, you will maybe see. It's kind of hard to read, honestly. If I go ls and then I try. Let's do lsal, and then I try finding for TTY USB 0. You'll see that there is actually TTY USB 0. That's not the case on everyone's computer. So when you plug in a microcontroller or something else, sometimes it might not be called TTY USB 0. It might actually be called TTY ACM 0. And so the reason that that's important is because, let me actually remember the source, so this will actually work. So if we go like source this virtual environment bin activate. So in the virtual environment, and the reason I'm in the virtual environment is because I want to go back into IDF path, I guess. And so from here, let's go into the, it's actually just hello world here. So the reason that this is all important is because when we actually did the make menu config command, it was basically asking us, hey, like, what do you actually want to set up this tool for? So when I go into Flasher, I didn't really go through anything in too much detail, but basically this first serial port thing is kind of important, because if your thing isn't called TTY USB 0, then when you try flashing, it's going to find something that doesn't exist, and then you're in trouble, right? So if your port is named something else, like, for example, ACM 0, right? Then all you'll go, okay, change that from USB 0 to ACM 0, or, whatever port it is that you're using. Press OK, and then save it, right? And so if you go exit like that, I'm going to do this on purpose because it's not going to work, but that's fine. So now if I try doing make flash, right, you'll see that it's trying to, it's having to remake the whole thing from scratch. Are you serious? Are you serious? I thought I made this already the first time. Anyway, so once it's finished doing that, what it will try to do, I guess because you've changed the path folder, so that's fine. But basically, it will try flashing on the ACM 0 port instead of the USB 0 port. And I just mentioned that because in the past, when I've had tutorials that I followed, it hasn't really gone over that because it assumes a lot of like Linux knowledge because like you're flashing to a microcontroller and you're using C and it's embedded and all this other stuff. But yeah, like if that's not obvious, I'll just pause that honestly. But yeah, basically what you'll want to do is just make sure that you actually change the port over here to the one that's actually on your machine. So let me just change that back for myself. But yeah, if that's different for you, if you're, I don't know, using like WSL or something, there'll also be like other hoops you'll have to jump through. You've probably figured those out by now as well. But yeah, no, like this is just another thing to take note of in case you weren't sure. And quick note, I'm also using the arrow keys. It sort of says that on the page over here. If I go ESP8, anyway, you can use the arrow keys to go around it here. So that's how I'm doing that. So I'll save that, press exit, and yeah, back to the tutorial. And so as you can maybe see from the time I've just logged back in, and so first thing I'll do is go groups. For the user, as we can see, it still says dial out, right? But what we're going to do now is first remember to source. So we'll go source ESP virtual environment bin activate. And now in the virtual environment, and now we will go to ESP hello world. And now I'm going to go make flash, and we'll see if it works this time. And so as we can see, flashing binaries because it's already built them. Connecting, chip is that, features, MAC address, all that other stuff. And so it's actually writing to the folder now. It's writing to the actual microcontroller, and that's working. And then one more thing we can do. So that's actually that's working now. Like we've got the tool chain set up, which is great. Let me actually open up Firefox again just to see what was the next steps for them. But I think we basically went through their tutorial. Next thing I want to show you is the make monitor command, which I think they also cover. But that basically lets you like snoop almost on like what the microcontroller is actually doing at any given time. We just run make monitor. In the folder, we will now see this is like something that the microcontroller is sending to us. So I think that's over UART. And if you want to get out of this, you can press Control, and then it's the forward like square closing bracket. It's this character. So Control and that will actually close the menu for you. And then there's like other stuff like help, and then like stuff like that. So if we try Control T, like Control H, for example, we can actually see some of these menu commands. So we're in the monitor thing, based on some menu term tool. That's to exit. That's the menu command. These are the different keys. So if you want to, I don't know, take a screenshot or something, that's probably useful, because I know I spent a while like, why isn't this closing? It's like, oh, it doesn't just use Control D like every other terminal, which I guess makes sense. But yeah, so if I do that, that closes out. Now I'm going to press it one more time, and it's that. And so what we can now do, I guess, just to see, okay, why is it doing this hello world and this is that, restarting stuff, is I'll actually just go into the source code for this. So I'll go into main, and then I believe it should just be hello world main.c. So vim, or actually I'll do code. Code dot, and that command will just open up VS Code in the current directory. So it's using the standard library, RTOS stuff, some ESP specific stuff, and then it's printing hello world, which looks like what it's doing. Let's just go over here somewhere. So it prints hello world, then it says this is the ESP chip with that many CPU cores, Wi-Fi, silicon revision that, and then 2 megabytes of external flash. So pretty interesting that it has all that, and then it's restarting in that many seconds. It uses a free RTOS command to go through, and then it restarts using the restart command. So yeah, that's a very basic example. Obviously, there's plenty of other examples if you just go into the... So remembering we were in the ESP8266 RTOS SDK, and then in here we went to... Oh, sorry. CD ESP, yeah. And then we go CD examples, and so you can see that there's the get started one, which just had the hello world, but there's plenty of other stuff, for example, in peripherals and protocols, storage system, Wi-Fi, like there's just to give an example, peripherals, there's, I believe, stuff on, so the ADC, different GPIO pin stuff, hardware timer, I2C, I2S, I think that's maybe some sort of infrared stuff, PWM, SPI, you get the idea. There's plenty of different functions for this board, and yeah, it's just a bit more of like if we go into, I guess, let's try the I2C one, because there's probably a bit going on in there, or maybe we'll go for SPI actually. So from here, if we go to just normal performance, I guess SPI master probably is how I have it configured. Go to main, and then we look at the SPI master example that it's got here. So it's just going to open it up in a second. I'm not going to click off that. I guess I trust the authors. We open. Again, it showed that thing and I just missed it. But yeah, basically it's like you've got all this different example code, and it's using some like free RTOS commands as well, which makes sense. But there's an ISR, for example, and this is like you can have a read through this. I'm not really sure exactly what it's doing, but yeah, I'm sure with enough time anyone can really figure it out, and that's the idea. So yeah, hope this tutorial was useful, and yeah, thanks for watching.